Hello, welcome to Meet Maths. Let's look at this question. So, derivative of 2 raised to the power x. So, derivative of 2 raised to the power x. Let's write our solution. Let's repeat this one. Now, we are going to put y equals 2 raised to the power x. We are going to put y equals 2 raised to the power x, okay? Y is equal to 2 raised to the power x. Here we are going to take natural log of both sides, okay? Natural log of both sides. So take ln of both sides. Now let's take ln y is equal to ln 2 raised to the power x. Now from the laws of logarithm, these two here can be written at the back here, okay? ln y is equal to x ln 2. ln y is equal to s ln 2. Okay, here we are going to differentiate. Here we are going to differentiate, okay? So differentiate. Now when you differentiate L and Y, we are going to get 1 over Y dy. 1 over Y dy. And now when you differentiate this, x ln 2, now we have to use the product rule to differentiate this one. If you use the product rule, first you just maintain x and then you differentiate this one. This one is a constant, so when you differentiate it, it will be 0, and 0 multiplied by x will give us what? 0, okay? So the next one is we maintain this one and then we differentiate this. Now when you differentiate x, we are going to get 1. 1 times ln 2 will give us what? ln 2. So when you differentiate this, we are going to get 1 over y dy is equal to ln 2 dx. 1 over y dy is equal to ln 2 dx. Okay, now we need to get dy over dx. We need to get dy over dx, but here we are having 1 over y dy is equal to ln 2 dx. So what you are going to do is that you are going to multiply through by y over dx. Sorry, we are going to multiply through by y over dx. Okay, so multiply through by y over dx. Now when you multiply through by y over dx, it's going to take away this, will take away this, and then this will also take away this, and we will get our dy over dx. Okay, so let's multiply it through and see what will happen. Now y over dx multiplied by 1 over y dy is equal to ln 2 dx multiplied by y over dx. Now here, this y will cancel out with this y, and it will be left with dy over what? Dx. Now when you come here, ln 2 dx multiplied by y over dx. Now this dx and this one also will cancel out, and it will be left with ln 2 multiplied by y. Okay, dy over dx is equal to y ln 2, but we know that y is equal to 2 raised to the power x. So we have to put it back because we made a substitution, or we put y equals to 2 raised to the power x. So if here we have, if we are having y here, all we have to do is to replace 2 raised to the power x with it. Okay, so but y is equal to 2 raised to the power x. So wherever we see this y, we are going to put this one there. Okay, so let's put it there. dy over dx equal to 2 raised to the power x ln 2. dy over dx equal to 2 raised to the power x ln 2. Okay, therefore yeah, dy over dx equals to 2 raised to the power x multiplied by ln 2. Now, therefore, the derivative of 2 raised to the power x is equal to 2 raised to the power x multiplied by ln 2. This one, there will be no constant because when you differentiate, the constant is what? 0. Okay, if it were to be integral, then we will bring the constant c. Okay, so when you differentiate this one, this is what you are going to get at the end of the day. Okay, all right, that's it. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.